A filament of a 240 volt 100 watt electrical lamp heats up from room temperature to its operating temperature. As it heats up, its resistance increases by a factor of 16. What was the resistance of the lamp at room temperature? Well, firstly, what we're going to do is we're going to find out, well, what was the resistance normally when this thing is just operating at a normal temperature. So P equals V squared over R is our equation. If you rearrange it, R equals V squared over P. We're going to find what's the resistance when this filament bulb is at its operating temperature. So let's put some numbers in. So 240 squared divided by 100. That's equal to 576 ohms. So this is at the normal temperature. So at room temperature, the resistance is going to be lower by a factor of 16. So divide by 16. And we get an answer of 36 ohms, which is answer A. The diagram shows connected wires which carry currents I1, I2, I3 and I4. The currents are related by the equation I1 plus I2 equals I3 plus I4. Which diagram does this equation apply to? Well, we could have either I1 and I2 going in and I3 and I4 going out. So that's C. You can see I1 is going in, I2 is also going in, I3 is going out, I4 is going out. Which physical quantity would result from the calculation in which a potential difference is multiplied by an electric charge? Well, voltage is equal to energy divided by charge. So if you times voltage by a charge, you'd get energy, which is B. The current in a component is reduced uniformly from 100 milliamps to 20 milliamps over a period of 8 seconds. What's the charge that flows during this time? Well, let's find out. Well, what was the average charge that flowed? So we do 100 divided by 2. So we get 120 divided by 2 is 60 milliamps. 60 divided by 1000 is going to give us our current in amps. Then we're going to use the equation Q equals I times by T. 0.06 times by 8 is 0.48 coulombs, which is, if we multiply that by 1000, we get 480 microcoulombs, which is C. The EMF of a cell in the following circuit is 9 volts. The reading on a high resistance voltmeter is 7.5 volts. What's the current I? Okay, so we're going to apply our formula that EMF is equal to the external PD plus the internal potential difference. Now we know that we've got our EMF here, so that is 9 volts. But this here, we're told, is 7.5 volts. So we want to find the current. Well, 7.5 is equal to I times by 15. So 7.5 divided by 15 equals I, which gives us a current of 0.5 amps. B. The diagram shows an arrangement of 4 resistors. What's the resistance between X and Y? Well, firstly, let's try and simplify the resistors in series. So here we've got 16 kilo ohms. Here we've also got 16 kilo ohms. Then we're going to do 1 over RT equals 1 over R1 plus 1 over R2, because now we've got effectively two 16 kilo ohm resistors in parallel. So 1 over 16 plus 1 over 16, we get 2 over 16. So therefore RT is equal to 16 over 2, which equals 8, and I kept the units in kilo ohms, so therefore our answer is B. Which electrical component is represented by the following symbol? Well, this part here is a resistor. This represents light going inside, so it's a light dependent resistor. Coulombs flows through a 12 watt light bulb in a time of 50 seconds. What's the potential difference across the bulb during this time? Well, V is equal to energy divided by the charge, and power is equal to energy over time. So power times by time is going to give us the energy. So 12 times by 50 is equal to the energy, which is equal to 600 joules. And now we know we've got 600 joules divided by the charge, which is 100, gives us 6 volts, which is C. The diagram shows a low voltage circuit for heating the water in a fish tank. The heater has a resistance of 3 ohms, the voltage source has an EMF of 12 volts and an internal resistance of 1 ohm. At what rate does the voltage source supply energy to the heater? Okay, so big R plus I little r. So we have got 12 volts is equal to I. R is 3 plus I, the internal resistance of 1. So the current is going to equal 3 amps. So at what rate of voltage supplied energy to the heater? So we want to find out the rate. So power is equal to current squared times the resistance. Well, we want to know the supply going to the heater, so we're only going to look at the resistance for the heater. So we've got 3 amps squared, and the resistance of the heater is 3. So we've got 9 times by 3, which is 27, which is A. A power cable X has a resistance R and carries current I. A second cable has a resistance 2R and carries current of half of I. So what's the power? Power is equal to I squared R. And we're asked what is the ratio of power dissipated in Y against power dissipated in X. Well, the resistance of X compared to Y is over 2. The current of X is twice that of Y. So now we're going to do I squared of Y divided by and we're going to substitute this and this in. We end up with I squared Y over, we've got 2I squared and then RY over 2. Now we can start cancelling stuff out. We end up with 1 divided by 4 times by a half, which simplifies to 1 over 2, which is B. A Current in a resistor is 8 milliamps. What charge flows through the resistor in 0.02 seconds? Well, Q equals IT. Our current is equal to 8 milliamps, which is the same as 0.08 amps. So Q is equal to 0.008 multiplied by 0.02, and you get an answer of 1.6 times 10 to the minus 4 coulombs, which is the same as 0.16 millicoulombs A. 6 resistors, each of resistance 5 ohms, are connected to a 2 volt cell of negligible resistance. What's the potential difference between X and Y? Well, firstly you need to look that these are all connected up here, but there's no connection here, whereas these are all connected up here and there's no connection here. So the equivalent of here is as if we've got 10 ohms. Likewise here it's as if we've got 10 ohms. Okay, so here we've got 0 volts. So at X we're going to have 2 times by 10 over 15 volts, and at Y we're going to have 2 times by 5 over 15. So here we've got 1.33 recurring, and here we've got 0.66 recurring. So what's the difference? Well, 1.33 minus 0.66, you get 2/3 of a volt, which is A. A wire carries a current of 2 amps for 1 hour. How many electrons flow past a point in this time? Well, we've got 1 hour, which is 1 times 60 by 60, which is 3,600 seconds. Then we need to know, well, what charge flowed in that time. So Q equals IT. So we've got 2 times 3,600 gives us a total charge of 7,200 coulombs. Now the magnitude of the charge of an electron is 1.6 times 10 to the minus 19 coulombs. So how many electrons is it going to take? And we get an answer of 4.5 times 10 to the 22 electrons. The diagram shows a circuit in which the battery's got a negligible internal resistance. What's the value of the current I? So firstly, what I suggest we do is we find out the total current. So let's work out what the total resistance is. So we've got 6 ohm and 3 ohm in parallel. So 1 over 6 plus 1 over 3. Well, that's going to simplify to 1 over 6 plus 2 over 6. So 3 over 6 equals 1 over RT for the parallel section. So 6 divided by 3 is 2 ohms. Okay, so we've got 2 ohms, the equivalent of 2 ohms here. Okay, so the total is going to be 2 plus 2, which is 4 ohms. So therefore the current coming out of here is going to be V over R equals I. So 12 divided by 4 equals 3 amps. Now because the equivalent resistance across here is 2 ohms, and we've got 2 ohms here, the 12 volts is going to be shared between here and here. So we've got 6 volts across here, 6 volts across here. So that means that across here we've got 6 volts. So if we've got a voltage divided by our resistance, we're going to find our current. So 6 divided by 6 is equal to 1, which is answer A. The diagram shows 4 heaters and the current in each. Which heater has got the greatest power dissipation? Well, power is equal to I squared R. So for the first one, we're going to do 8 squared times by 2. The second, we're going to do 6 squared times by 4. And we're going to do 4 squared times by 6. And finally, 2 squared times by 8. So let's plug these into a calculator and see what values we get. So the first one, we've got 128 watts. Next up, we've got 144 watts. Then we've got 96 watts. And then finally, we've got 32 watts. So the greatest value there is B. The diagram shows a junction in a circuit where 3 wires P, Q and R meet. The current in P and Q are 1 amp and 3 amps respectively, the diagram shown. How many coulombs of charge will pass through R in 2 seconds? Well, if we've got 1 amp going in and 3 amps leaving, therefore we're going to have a current of 2 amps in this direction. So how many coulombs of charge pass a given point in 5 seconds? So Q equals IT. We now know it's 2, so 2 times by 5 is equal to 10 coulombs, which is D. The resistance of a device is designed to change with temperature. What's the device? Well, thermistor comes from 2 words. Thermal, meaning heat, and then resistor. So I'm pretty confident the answer is D. A battery of negligible internal resistance is connected to 2 10 ohm resistors in series. What charge flows through each of the 10 ohm resistors in 1 minute? Well, if we've got 10 and 10, the total resistance is going to equal 20 ohms. So therefore the current is going to equal 6 divided by 20, which is 0.3 amps. So what charge flows in 1 minute, which is 60 seconds? So Q equals IT, which is equal to 0.3 multiplied by 60, gives us a charge of 18 coulombs, which is the charge that a fully charged 12 volt car battery can supply is 100 kilocoulombs. The starting motor on a car requires a current of 200 amps for an average period of 2 seconds. The battery doesn't recharge because of a fault. What's the maximum number of times the starter motor of the car can be used? Okay, so we want to know is how much charge we can use in each time the starter motor is attempted to be used. We have 200 times by 2, which is 400 coulombs. Now, the car can supply 100,000 coulombs. So 100,000 divided by 4, well, sorry, 1,000 divided by 4 is 250, which is D. The potential difference across a resistor is 12 volts. The current in the resistor is 2 amps and 4 coulombs of charge passes through it. What's the energy transferred and the time taken? Well, Q equals IT. So Q over I equals T. So 4 divided by 2 equals 2 seconds. So we're looking at either A or C. And then finally, what's the energy transferred? Well, voltage is equal to energy divided by the charge. So the voltage times by the charge is equal to the energy. So we've got 12 multiplied by the charge, which is 4, which is going to be 48 joules, so therefore the answer is C.